Hello everyone, and welcome to my channel. In the previous video, I created an ocean mesh and simulated surface waves. However, the ocean appearance seemed artificial, so I'm aiming to achieve a more realistic look using a custom shader. I want to incorporate reflections on the water surface, foam at the water's edge, and slightly transparent shallow waters. Shaders are a powerful and cost-effective way to enhance visual quality as they work on the GPU, allowing faster mathematical calculations with fewer polygons and lighting computations. During the creation of the ocean mesh, we focused on holding 3 vertex pieces of information for each triangle. Less polygons mean less GPU work. I must admit, I'm not an expert in shaders, so I'll proceed with a trial and error approach to begin my custom shader adventure. To maintain organization, I create a folder named Shader and add a URP lit shader graph underneath it. I choose lit because I want it to be affected by light. I aim to create a flow on the water surface using normal maps. For a continuous flow, I add a time node. Since I'll use 2 different normal maps, I obtain 2 different values by dividing the time node into different values. I add a property to be able to change the tiling value from the inspector and connect it to the tilling and offset nodes. Now that I have UV coordinates for normal maps, I can create texture connections by adding the sample texture 2D node. I also want to change normal maps from the inspector. I use the add node to merge these 2 normal maps. I add the strength of the created normal map as a property for fine details and connect it to the shader's normal map output port. I change the property mode to slider to limit the range of the normal strength property. I found 2 wave normal maps on the internet, imported them into my project, and instructed my ocean material to use my created ocean shader instead of the URP lit shader. Pressing play to see the result seems to show no change. To avoid running the scene each time to see shader results, I create a plane in my scene and assign the material to it, allowing me to preview the results without starting the game. Still, there's no change. I check whether my URP asset allows depth texture and opaque texture, but at the moment, it seems unrelated to the issue. It's nice to see they are active since we'll use them later. I add base color and smoothness to check if my shader works or not. The smoothness value should be between 0 and 1, so I convert it to slider mode. Finally, I realize the issue is on my end. I haven't increased the normal strength property, and I haven't scaled my plane object or changed the tiling value. Hey, I already told you guys, I am not an expert. But I still managed, didn't I? Now there's some movement on the surface. No need for fine-tuning at the moment. Since the adjustments for the normal map work, I can return to the shader graph and continue my modifications. To work with different groups, I group the normal map nodes. I connect the node links that calculate the depth of objects on the screen. Scene depth represents the pixel depth in the scene, and far plane determines the camera's viewing distance. Screen position, raw, provides the raw screen coordinates of a pixel. Maintaining a neat shader graph is crucial, otherwise it can lead to confusion. Because of a wrongly placed connection, the results can be completely different, and since I'm not an expert, detecting errors can be challenging. So, I group the properties as well to keep them tidy. To create a transition between two different colors, I generate the alpha value of the calculated depth. I experiment with changing the values to see what happens. Although my material is transparent, reducing the alpha value of the coastal color doesn't seem to create transparency. This is because I haven't connected this alpha value to the shader output, so the shader isn't applying any alpha transparency. I group the newly created nodes as well. Now I want to create an image resembling foam at the shores. Again, I perform depth calculations using scene depth and scene position. There should be some movement in the foam, so now that I have achieved movement, I combine it with a visual. After thinking for about 1 millisecond between using foam texture and noise, I decide to use gradient noise. I create a property to receive how far it will progress from the coast and calculate the distance and movement. I want to combine this with a Fresnel effect to get a brighter appearance at the edges. Now that I've calculated these, I can combine them and give color. I include the foam we created in the color output and can now see the result. The foam size turned out to be larger than I expected, so I multiply the scale value we send to the shader by 100 to obtain a larger tiling value. Now, by playing with the values, I can achieve a pleasing look. Although the ocean surface appears shiny, there is no reflection on it. For this, I found a package on GitHub owned by Ch-3D. With this package, we can create reflections at any desired point and get the result as a render texture. So by connecting the texture obtained from here to the shader, we can create reflections on the ocean. You can find the link below. After downloading and extracting the package from the zip file, we import it from the package manager. The height of the object to be created must be the same as the ocean, and x and z coordinates are not important for us. After adding the mirror script, we can see the mirror image in the scene view. I'm temporarily turning off occlusion culling for cameras. I don't want it to give an error since I'm not doing occlusion calculations. I'm ready to add the reflection feature to the shader. First, to create a fraction on the mirrored image, I take the height of my object and add it to the height of the normal map. I want to change the height of my reflection according to the value coming from the power property. By adding the resulting value to the screen position, I now have a distorted UV. I will combine this UV with the reflection map. I create a property called reflection map. I make sure that the reference property is underscore reflection map because the mirror script sends information to this reference. Our reflection group is ready. Now we need to connect the obtained reflection to a place on the base color. With the blend function, I connect the image obtained before the frothy process. This way, the reflection will be below the frothy image. I also set exposed to false. The shader is completed, and this is its final form. Now it's time to play with the values until we get the best visual. The reflection doesn't look quite right because I set its rotation to 90 on the x-axis, whereas I should have rotated it in the -90 direction. I'm also resetting the offset of the mirror script to 0. After fixing this, I can play with the shader properties until I get the best visual. Thank you all for watching my video. I hope you enjoyed it. In the next episode, we will achieve a better visual by adding a global volume. Also, we will address issues with terrain tiling to obtain a better visual. Don't forget to subscribe to my channel to follow the continuation of the series and stay informed about new content. I will continue to share many creative and informative contents with you. Happy watching!